Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, today for our lesson 3.2.5, this is actually a day where it would be kind of fun to be together, um, because there's a game that we're gonna play, where you get to actually test your skills with the integer operations. That is adding, subtracting, and multiplying. We're not going to work too much with dividing, although I suppose we could, but no. Um, Integers, both positive and negative. Okay. Um, there is a way that you can do this particular game online, and I'll show that to you in a second. But first, let's read the preview here. In this lesson, you will have an opportunity to practice adding, subtracting, multiplying, and dividing integers. I'm not sure how much dividing we're going to do. As you play a game against a partner, which you're just going to watch me play it, and then if you want to, you can access the game online and play against someone at home. As you play, consider these questions. Which operation will these integers, with these integers, will move us farthest? Which operation with these integers will move us in the direction we want, and will any operation with these integers allow us to win? All right, so this is the game that we're going to play. It's called Tug of War, and I'm not going to give you the resource page. You don't really need that. You can just draw a number line to make this work. And the number line would look something like this, where everybody starts on the number 0, and you got a number line that goes all the way up to 15, all the way back to negative 15, and your goal is to be the first person to land on either positive 11 or negative 11. It doesn't matter which one you land on, okay? Now, I've got a spinner here that I'm going to spin. That looks kind of freaky right there. Come up, spinners, let's go. All right, there you go. So we will spin these spinners, and hold on, let me get that other. All right, that wasn't a ice. Well, okay. So what we do is this: I'll spin the spinners, and there's going to be one number from this spinner and one number from this spinner, and you can either add the numbers together, you can subtract them in any order, you can multiply them, or you could do a division. And I'm not quite sure that we're going to be dividing too much. Come on, hold on for a second. This is bugging me a lot. Hold on. I'm really glad you didn't hear me yelling at my computer right there, but I've got things settled. Okay, so what we do is, let's go ahead and I'll just put this green guy right there. So I'll demonstrate for you how this would work. So we're going to spin both of them, and I got the numbers -3 and 0. So if I choose to multiply those two numbers together, my product would be 0, and I wouldn't move anywhere. If I choose to add them together, -3 plus 0 would move me 1, 2 to -3, because their sum is -3. If I were to choose to do a subtraction, I could actually take 0 minus a -3, and doing KFC, that becomes 0 plus 3, which would give me +3, which would move me to over here. So I would have the option of doing any of those, and I'm just going to choose to go in the easiest direction. -3 plus 0 is -3, and we'll call it good. Okay, so then we spin again, and now we've got 1 and 3, and I'm already going in this direction. So maybe I'll choose to say 1 minus 3, which would be -2, which would move me 2 more units toward -11. So now I'm pretty much committing to try to get to -11 here, since I'm much closer to this than I am to that. How many do I need to go? I need some way to get a combination so far of -6. Now, if I were to go you're not allowed to go beyond -15, just like you would not be allowed to go beyond +15. So whatever combinations of numbers that I get, I am not allowed to go in that direction where it goes beyond -15. So here I've got -3 and -1. I think what I'll choose to do is add those together, which would give me -4. So I would go 1, 2, 3, 4. And then for our next spin, I got -2 and -2. How does this help me? I really want the -2 plus 0. Is there any combination here where I can make these? I think what I'm going to do, I lied earlier. I said I didn't see being able to divide anything, but if I take -2 and divide it by -2, that'll give me +1. And I'm going to go ahead. Oh, wait, hold on for a second. No, I'm going to say -2 minus a -2 is 0, so I will stay where I am. Yes, that's what I'm going to go with. And then -3, and that's the winner right there. Here's why it's the winner. I can get a -2 out of this. If I say -3 minus -1, and I do KFC, and I'm going to change this to plus a positive, and -3 plus +1 is -2, and that's what lands me on the winner. Okay, now the thing that makes this a little tricky is when you've got multiple people playing, you all use the same numbers, but people can choose to do different operations with those numbers, and someone may have chosen to go this way. And if you choose the right combination, you might get to the 11 or the -11 quicker than anybody else. Okay, so let me show you online. So here's lesson 3.2.5, and problem number 78 is the tug of war game. If you really wanted to download this, you could. It has the number line on there, but I don't really see why you would need to have all that. It's just as easy to create your own number line, but this is the tool that you can use from home. Okay, so pick a token. You can have as many as 6 different people playing. Okay, and then you stop it. See it. There you go. Click it in the middle, and here you've got. Oh, why is it on a line? Seriously. There you go. -2 and +1, and so you can go ahead and play this with anybody. You can play with 2 people, 3 people, 4 people. You can see how quickly it takes you to become a winner if you just want to play it on your own. Feel free to have fun with that. And along the way, you're practicing your mental skills for dealing with integer operations. Okay? Now, this we're not going to be able to do. Discuss with your team and then as a class strategies that you use or discovered. It might be good to think about strategy, but you're going to have a tough time discussing it unless you got a family member who's willing to discuss that with you. All right, so here's where we can discuss 4 different scenarios. Cynthia, Devin, Gavin, and Mark are playing the tug of war game. Cynthia begins her turn where her marker is on 15. So remember, she's on 15, so she needs to move backwards 4 spaces to get to 11, and she spins a 1 and a -3. Can she make it with those 2 numbers? Is there any way to get from 15 to 11 using those 2 numbers? For B, Evan takes his turn. His marker's on the 1. He spins a 4 and a -3. Is there any combination of operations with a 4 and a -3 that could either get her or him to 11 or -11? Gavin is on 12, and he spins a -3 and a -2. Gavin is wondering if he can make it to either 11 or -11. And then Mark is at -14, and he spins a -11 and a -1. So what I'd like for you to do is take a little time, see if you can figure out a combination or an operation that can be done with these numbers for each one of the given players that would land them on either 11 or -11 and create a winning scenario for those players. Okay, go ahead and pause, and I will reveal what I've figured out. All right, let's see what we got. Cynthia, is there a way to make this work? I'd say yes, she can win. If she subtracts 1 from -3, which would be -3 minus 1, which is the same as -3 plus a -1, that would be -4. And then you take 15 plus a -4, or 15 minus 4 would land her at 11. So she would be a winner. Kevin, could he be a winner? Yes, he can. If he chooses to multiply 4 times -3, that would give him -12, and then you add that to the 1, and that would place him at -11, which is a winner. How about Gavin? Can Gavin win? Absolutely. He can subtract -2 from -3. And when you say -3 minus -2 and do KFC, that becomes -3 plus 2, which is equal to -1. And 12 plus the -1 is 11. And then the last one being Mark, who's at -14. What do we have here? Absolutely. He can multiply -3 times -1. And that's going to get you 3, and then take 14 minus the 3, and that would put you at 11. Actually, does that work? Hold on for a second. I think if that's 3, then that would have to be 17, right? I'm going to have to explore this a little bit. How can we make this work? Let me pause that for a second and see. Aha, I knew Mark could win. I made a very simple mistake, but now it's been fixed. Yes, -3 times -1 gives you +3, but he was at -14. So it wasn't 14 minus 3 is 11. It was -14 plus 3 lands him at -11. So all of these, with these scenarios, could win on their next move with these given spins. All right, now we're going to have to do a little exploration, and I'm going to give you, you're going to take a little time on this, but I'll reveal what I found out. So Roger went home to play tug of war game with his brother, his older brother, Hank. Hank looked at the spinners, thought for a bit, and then told Roger that the game is flawed because you cannot get all of the integers from -10 to +10. Roger wondered if Hank was right. Are there any integers, any possible answers from adding, subtracting, multiplying, and dividing combinations of these numbers from each spinner? Are there any integers that you would not be able to get as an answer in one particular move? And even if there were, does that really make the game flawed? I mean, is there any rule that says that you have to be able to land on every single one of those numbers? I'm not quite sure what Hank is getting at. Maybe he just doesn't want to play the game because he doesn't want to be bothered by his younger brother, but whatever, that's a different issue. So this is what I would like for you to do. I would like for you to take one number, create a list, any strategy that you want, but take one number from this and one number from that, and test what would happen if you added them, subtracted them, multiplied them, and or divided them. And as you find a total sum, difference, product, or quotient that appears on this list, then cross that number off. And if you find another combination that makes that same number, don't bother working that one out, because what's the point? You've already crossed it off the list, right? And we want to see if we can compile a list of every single possible combination to see if we can hit every single one of these numbers with any given term, okay? So I've got mine there already, and I'll do the reveal after you've had a chance to make your list. But seriously, do this. See how many different ones of these that you can find an answer for, and if there are any that you can't get an answer for, making Hank sort of correct with his claim, okay? All right, I'm assuming you just paused and aren't just waiting for me to give you all the answers, but even if I did give you all the answers, not that big of a deal. Come on, let's reveal. Okay, so here we go. I started doing the systematic list, and I started with the upper left-hand corner. -2 and 0 is -2, so we can go ahead and spotlight the -2. That works. -2 times 0 is 0, so we can remove that from the list. -2 plus a -1 is -3, so that one stays there or is on the list. -2 minus a -1 would be like -2 plus 1, which is -1, so we can get that one. -2 times a -1 is +2, so let's get that guy. -2 plus a -2. Okay, so now I'm working my way around. I'm sticking with -2, but I'm working my way around this one. That gives us a -4. When you multiply them together, that gives us +4, because a negative times a negative gives you a positive answer. Now let's work our way. I think when I did -2 and 2, whether I multiplied them, added them, or did subtraction, it already accounted for all the possible answers, so I didn't bother putting that on the list. But When I got to -2 and 3, that combination gave me 1. And then -2 minus 3 gives me -5, so we'll include that guy. And -2 times 3 is -6. So we've got that guy right there. And that exhausted everything that I could do with the -2. And then I worked with the 1, and I found everything I tried to do with the 1 was already accounted for. I guess with the exception of, I guess there was 1 times 3 would have got me there, but then I ended up getting that here with the -3 and the -1. The -3 and the -2 gives us +6. The 2 minus the -3, I ended up taking this and doing a reverse order because that was allowed. You know, it didn't have to be the first number in the numbers sentence, and this the second one. You could have reversed them. So 2 minus the -3 ends up being 2 plus 3, which is +5. And then how are we going to get to 7, 8, 9, and 10, or -7, -8, -9, -10, unless, I mean, the 2's and the 1's aren't going to get there. I'm not even sure that the 3's, I guess the 3 times -3 will get us there. That gives us our -9. And then so I moved into our -4. So you got -4 minus 3 is the same as -4 plus a -3, which is -7. -4 times 2 is -8. Taking -4 times -2 was +8. Taking 3 minus the -4 is the same as 3 plus +4, which is 7. And I could not come up with any combinations that would give us 9, 10, or -9 or -10. Really, there's no way to add or subtract these numbers. They don't have absolute values. I'll get you to the 10 or the -10, and you get 4 times 3 is 12, but 12 isn't one of those numbers on there. So there's no way for us to do that either. So Hank was right that not every possible integer between -10 and +10 could be landed on with just one move. Okay, so the -9, -10, 9, and 10 are the 3 that you can't get to. However, who cares? That doesn't make the game flawed. It just means you're not going to win on the first term, because I'm not quite sure you can get any combination that would get you 11 or -11 in one term. So you're probably going to have to take at least 2 terms. Big deal. All right. So that's the lesson for today. It gave us plenty of opportunity to practice our integer operations. You know, really, this is absolutely critical. You need to, before you move on to high school, the Delaware teachers have told me this multiple times. If you cannot add, subtract, multiply, and divide integers, you are going to be stuck in the lowest level of 9th grade math until you master those skills. You will not be able to pass 9th grade math. You need to have those skills absolutely mastered. So the time is now. Show your work, complete these problems, make sure. It could take a month, it could take a week, maybe it only took 1 lesson for you. I don't know how long it's going to take you to have all of these operations mastered, but you've got to have them mastered. And once these are mastered, then it's going to make it easier to master the fraction operations, which are also critical for success in high school. Okay, so do your homework, copy down problems, show all of your work, and make corrections to any problem that you get wrong. Take care.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,